Students, this is Ramkishore, faculty in EC department, DBSIT, Kavali. So in today's class, I would like to explain about semiconductor devices. So before going to semiconductor devices, so first of all we have to know what is electronics and what are the electronic devices present in a different circuits. So initially, the electronics is the branch of science that deals with the study of flow and control of electrons and the study of their behavior and effects in semiconductors. So it is related with science, and it is a study of flow and control of electron. How the electron will start from one point and their ending to another point, and their behavior and the effects. What are the effects present within how the electron will move from one valence band to conduction band or conduction band to valence band. So that will be formed in a valid or a solid structure. So the electronics deals with the flow of the charge through non-metal conductors. So that is nothing but the semiconductor. So those electrons deals with the flow of charge through non-metal conductors. So those are nothing but silicon and the germanium. Those type of materials will be takes place in the form of semiconductors. And the electrical deals with the flow of charge through metal conductors. Those are nothing but copper wires and silver, aluminum. So those are coming to under the category of electrical devices. So for the example of the difference between electronics and electrical is the flow of charge through silicon, which is not a metal, would come under electronics, whereas the flow of charge through copper, which is a metal, would come under electrical. That means whatever that will be, the electrons will freely transferring from one end to another end. So that would become under electrical if those are partially flows through one point to another point. So that will come under electronics. So here based on, so we have to know what is insulator and the conductor and the semiconductor. We have to know the difference between these three materials. So first of all we have to see what is the difference between insulator and the conductor and the semiconductor. So mainly the materials are classified into three types. They are conductors and the insulators and the semiconductor. So first of all the conductor. So a conductor is an object or a type of material which has excellent current carrying capacity. Example is nothing but some metals. Metals are nothing but copper wire, aluminum wire, and the best conductor is gold. That means here there is no energy gap in between the conduction band and the valence band. There is no energy gap in between valence and the conduction band. And the next coming to insulator. So an insulator is an object or a material which does not allow current through it. Example is rubber and the wood. Those materials will come under insulators. So here we are having more energy gap in between the conduction band and the valence band. That means there will be no passing, the electron does not passing through conduction band to valence band because of the energy gap. So these finally semiconductor, it is nothing but semiconductor partially allows current through it. Example for those semiconductor materials are silicon and germanium. So these semiconductors are used in all electronic devices like cell phones, televisions, computers, radio and so on. So these semiconductors are classified into two types. They are intrinsic semiconductor and extrinsic semiconductor. So these insulators are very pure conductor of electricity is called insulators. So that is nothing but plastic, rubber, wood, diamond are some of examples of insulators. So in an insulator, the forbidden gap is larger than the concentration of free electrons is small. So due to that, the electrical conduction is impossible in an insulator because electrons require very high energy. The energy gap of an insulator is very large. It is generally more than 3 electron volts, and the electric field is applied in an insulator. An electron in valence band can overcome the forbidden gap to reach conduction band. So this is practically not possible. So that's why simply the energy gap, whatever the gap should be present in the conduction band to valence band, and conduction band to valence band is very higher. So due to this, the electron does not travel from conduction band to valence band. So due to this, the electron will not freely travel from one point to another point. So in this so now we will see what is a semiconductor. So how the semiconductor will play an important role in electronic devices. So semiconductors are mainly divided into 2 types. They are one is the intrinsic semiconductor and another one is extrinsic semiconductor. Intrinsic semiconductor and extrinsic semiconductor. An intrinsic semiconductor is also called an undoped semiconductor or I-type semiconductor. Is a pure semiconductor without any significant doping species present within the semiconductor. So that type of semiconductor is called intrinsic semiconductor. That is pure form of semiconductor is called intrinsic semiconductor. So in this, the number of charge carriers is determined by the properties of the material itself instead of the amount of impurities. So in intrinsic semiconductors, the number of excited electrons and the number of holes are equal. That means, so if intrinsic semiconductor, so in this, the number of electrons is equal to number of holes. So that will be defined in terms of n is equal to P. N is equal to P. So the electrical conductivity of intrinsic semiconductors can be due to crystallographic defects or electron excitation. In an intrinsic semiconductor, the number of electrons in the conduction band is equal to the number of holes in the valence band. So an indirect band gap intrinsic semiconductor is one in which the maximum energy of the valence band occurs at a different k vector than the minimum energy of the conduction band. For example, so we can include silicon and germanium. A direct band gap intrinsic semiconductor is one where the maximum energy of the valence band occurs at the same of k energy as the minimum energy of the conduction band. So examples for this one is gallium arsenide. So another one, a silicon crystal is different from an insulator because at any temperature above absolute zero, there is a finite probability that an electron in the lattice will be lose for its position, leaving behind an electron deficiency called a hole. If a voltage is applied, then both the electron and the hole can contribute to a small current flow. Due to this, it doesn't perform the electron flow from one point to another point. So the conductivity of a semiconductor can be modeled in terms of the band theory of solids. The band model of a semiconductor suggests that at ordinary temperatures there is a finite possibility that electrons can reach the conduction band and contribute to electrical conduction. So that intrinsic semiconductor, so in that we didn't do any type of doping. Doping is nothing but we are adding some impurity materials. So whenever we are adding the impurities, so then that will be converted into another type of semiconductor. So if we doesn't do any doping to a particular semiconductor, so that type of semiconductor is called intrinsic semiconductor. So the term intrinsic here distinguishes between the properties of pure intrinsic silicon and the different properties of doped N-type or P-type semiconductors. So in this intrinsic semiconductor, we are having some paired generation, that is electron hole paired generation. In an intrinsic semiconductor such as silicon at temperatures above absolute zero, there will be some electrons which are excited across the band gap into the conduction band, which can support the current flow. When the electron in pure silicon crosses the gap, it leaves behind an electron vacancy or hole in the regular silicon. So under the influence of an external voltage, both the electron and the hole can move across the material. In an N-type semiconductor, the dopant contributes extra electrons dramatically, increasing the conductivity. So whenever it decreasing and increasing the hole and the electron conductivity, so based on that we get the paired generation within the formation of electron and the hole will move from one side to another side. So in a P-type semiconductor, the dopant produces extra vacancies or holes which likewise increase the conductivity. It is however the behavior of the p-n junction which is the key to variety of solid state electronic devices. So in the same way, the conduction in intrinsic semiconductors is the current which will flow in an intrinsic semiconductor consists of both electron and hole current. So that is the electrons which have been freed from their positions into the conduction band can move through the material. In addition, other electrons can form the lattice positions to fill the vacancies left by the freed electrons. The additional mechanism is called the conduction because it is the holes are migrating across the material in the direction opposite to the free electron movement. So due to that, whenever the electron will crosses the hole and the electron, so due to this paired generation, the conduction will be considered in intrinsic semiconductors. The current flow in intrinsic semiconductor is influenced by the density of energy states, which in turn influence the electron density in the conduction band. So due to the conduction in intrinsic semiconductor, current is highly temperature dependent. Semiconductors are mainly divided into two types. They are first one intrinsic semiconductor, semiconductors, and next one is extrinsic semiconductors, Again, that the extrinsic semiconductors will be divided into two types. They are P type and another one is N type. So here, an intrinsic semiconductor. In an intrinsic semiconductor, the number of electrons in the conduction band and the number of holes in the valence band are equal. So it is also called pure semiconductors. Without any impurities in them are called intrinsic semiconductors. So pure germanium in intrinsic semiconductor at room temperature with a band gap of about 0.72 electron per volts. For germanium it is 0.72 electron volts. If the germanium will works like as a pure semiconductor. So similarly, pure silicon is an intrinsic semiconductor with band gap of about for silicon it is 1.1 electron volts, 1.1 electron holes. So at this temperature, the valence band is completely filled with electrons. So due to this, the number of electrons in the conduction band and the number of holes in the valence band are equal. So this type of semiconductors we call intrinsic semiconductor. An extrinsic semiconductor is one that has been doped, that is into which a doping agent has been introduced, giving it different electrical properties than the intrinsic pure semiconductor. So this doping involves adding dopant atoms to an intrinsic semiconductor, which changes the electron and hole carrier concentrations of the semiconductor at thermal equilibrium, the temperature at which two adjacent substances exchanges that no heat produced within the semiconductor. So then the dopant carrier concentrations in an extrinsic semiconductor classify it as either an N-type or P-type semiconductor. The electrical properties of extrinsic semiconductor make them its essential components of many electronic devices. That means an extrinsic semiconductor is one which contains small quantities of selected impurities introduced into an intrinsic semiconductor. So this process of introducing impurities in small quantities into a material is called doping. So the main difference between intrinsic and extrinsic semiconductors are, so in intrinsic semiconductors we didn't perform any doping concentration in intrinsic, but an extrinsic semiconductor, so we have to some of the doping will be performed to an intrinsic semiconductor, then it will convert to an extrinsic semiconductor. That means doping will be done in the extrinsic, and doping we didn't do doping in the intrinsic semiconductor. That is the main difference between intrinsic and extrinsic semiconductor. And the comparison between this N-type and the P-type semiconductor is an extrinsic semiconductor which is obtained by doping the impurities atoms such as antimony, phosphorus or arsenic to the pure germanium or silicon semiconductor. That means if you want to form a N-type semiconductor, then it will be, we have to add some doping materials for N-type. Those are nothing but antimony and the phosphorus arsenic. So if we want to form a P-type semiconductor, it is an extrinsic semiconductor which is obtained by doping trivalent impurity atoms such as boron, gallium, indium, to the pure germanium or silicon semiconductor. That means if you want to form a p-type extrinsic semiconductor, then we have to add the trivalent impurities. Those the materials are nothing but boron, gallium, indium. And the next difference between n-type semiconductor and p-type semiconductor is the impurities atoms added to provide extra electrons in the structure and are called donor atoms. That means whenever we are adding pentavalent impurities to n-type semiconductor, so then that will provide extra electrons in the structure. So those are called donor atoms. Next, in case of p-type semiconductor, the impurity atoms added, so it creates vacancies of electron, that is holes in the structure, and are called acceptor atom. That means in n-type we are having the donor atoms, and in p-type we are having acceptor atoms. And the next one, the electrons are majority charge carriers and holes are minority charge carriers in n-type semiconductor. So we are having the donor. Based on that reason, electrons are the majority and holes are minority carriers. So in case of p-type semiconductor, so it is holes are greater than the electrons. So that's why the holes are the majority carriers and electrons are the minority carriers. So these are the main differences between n-type semiconductor and p-type semiconductor. In p-type semiconductor is formed when a small quantity of acceptor impurity